Laura Obadell, Calico Rollinson, Mara Anderson, Jillian Heitland, Anne D'Amico, Haley Crowder, Rochelle Jones, Chase Schilling, Colin Schoeneman, Emily Schreiber. Please come to the office.
Do I gotta sit somewhere else today?
Yes. Preferably.
Okay. I'll drop my glasses today.
Staff may have your attention, please. Band got out just a little bit late. Please admit them without passes. If you did not vote for King and Queen candidate yesterday, please come to the office this time. Haley Crowder, come to the office. Calico Rollinson, Mara Anderson, Jillian Heitland, Anne D'Amico, Haley Crowder, Chase Schilling, Thomas Schorman. Please come to the office.
Okay, you'll need your notes today. Actually, you can sit right there unless the band never comes back in. All right, we're gonna do a couple notes today. That's all we're gonna do. We're gonna do kind of a PowerPoint today. So if you want to take out your notes, we're gonna do that. Again, when I do PowerPoints, I'm gonna post them on online, so you can actually click through them. You can save them yourself. I'm just kind of waiting for the whole thing to get here. So just take your notes out. That's all we're gonna do today. We'll try to take a look at your. Your notes we did, or the test, I mean, that we did yesterday, later this week. So we're not going to do it right away. Okay, here we go. Let me see if this works. It should. Perfect. Okay. Today, we're going to be working with three-dimensional objects. That's what we're looking at. We're just looking at a couple notes. It's the last section that I didn't put on the Chapter 1 test. It wasn't a big deal. There's not a lot we can do with this. But I do want to talk about it. There's a couple of figures that eventually in this class we do need to be able to handle. And I want you to sound at least intelligent when you're actually talking about those actual vocab terms. So, slide will have a lot of pictures, a lot of diagrams to show you kind of the idea of what I'm talking about, so I don't have to try to attempt to draw these pictures because they get a little difficult. But again, we're messing with three-dimensional objects, not two-dimensional. Two-dimensional is for like the polygons or some of like the circles that we messed with the other day, or ellipses. So those are the ovals. But today we're dealing with three-dimensional objects. This is the hardest thing for people to understand when you take a three-dimensional object and you put it on a piece of paper. It's just difficult to see that. You guys even had that problem on your test the other day. I think it was like problem number like 2, where that line was poking through the paper, right? It was going straight down. That's really difficult to see. So you got to get used to like the dashed lines and other things. So if you're not quite getting these, I understand. We'll try to do the best you can. Basically today is just about definitions. Whatever we don't finish today, we'll finish tomorrow. So we're not in any rush by any means. I just thought this is easier showing you this than trying to write down everything by hand on the board, because there's a lot of different terms that a lot of people don't realize. Okay? Alright, so does everyone understand what we're going through today? Okay, so we'll start here with the outline. I always like to give you an outline of kind of what we're doing here today. I usually write on the board, but it was just kind of easier typing it out so you can see, because there's quite a bit of stuff here. All right, so the number one thing that I do want to talk about, definitions. That's like our main goal today. To look at like the names of these objects, but define them, know what they mean. Like, why is this shape called this versus something else? That type of thing. We'll talk about what we call the polyhedrons, or polyhedra for plural. Those are the names of shapes that are three-dimensional. A lot of people don't know that. Polyhedra is the correct name for shapes. Now there's other names. There's things that fit this category of polyhedron and not polyhedron. So we're going to try to discuss that today. Okay? So that's kind of what we're going to go to. That's a majority of our notes right there. Okay? Then what we'll do is we'll talk about what a face is of this object. You know, what the edges are. Vertices or vertex. We've seen those words before. These two especially. Now on polygons, we should understand this. In fact, these two definitions are actually the same definitions as what we use for polygons, but now we apply them to three-dimensional objects. The face is probably a new one. We haven't just seen that yet. Obviously, we're going to talk about prisms. Right? Prisms are types of polyhedrons. There's certain types of prisms that we're going to have. We'll try to define what this word means so that you understand like what it looks like. Why is it a prism versus just a regular polyhedra, that type of thing. We'll talk about the different forms of pyramids today, if we can. And then, okay, cylinders. So these three objects, basically, these three are basically the main shapes that people think about when they think of three-dimensional objects, these objects. Now, obviously, cylinder has a couple different types. You know, cylinders, a round object. You need to go get it. A cone is another one that it really mimics the shape of a cylinder. They have almost the same definition. It's just a slight difference. And then obviously a sphere. These are the curved edges. Okay, so those are the main differences. But most people think of these three right here when they think of the polyhedra. Okay, and then obviously we're going to talk about what regular means according to this, because we've discussed regular, right? We've had regular polygons, like a square or the equilateral triangle. That was actually part of your last test, right? You had to name an object that was regular or irregular. And then the platonic solids. This is probably a term you've never seen before. People that would recognize this term would be people that play board games that require certain So, like the one that I can think of a lot is like Dungeons and Dragons. If you're into that type of thing, the role-playing board games and stuff, you'd probably be really familiar with these objects, which they're no different than the others, the other shapes that we're going to see, but they fit with this term, the idea of regular. That's why we have them. Then obviously we're going to finish with surface area and volume. That, I can guarantee, these two topics are the ones we're going to discuss tomorrow. Okay, like how we find surface area, how you find volume for these objects. We'll try the room first, and then we'll try other shapes, so you can see how we apply them. But again, it's area and volume. So that's kind of the main two objects. So that's your outline. As you can see, there's a lot, right? We have a ton of stuff. So we don't finish today. We'll try to work our way through tomorrow. That's kind of where we're going to go today. Now, obviously, let's start with the polyhedron. Let's actually get like a definition of what that thing looks like. I'll give you a picture of one so you can understand some of the terms that we're going to use, like especially faces. We have different names for like a face. So, all right. Any questions, comments, concerns on what we're going to talk about today? It's a lot, I know. Okay, let's jump right in. Let's talk about the polyhedra, or polyhedron for singular. The polyhedron, by definition, is a solid, right? It's a solid figure. So it's got flat surfaces that are enclosed with that enclose a single region or space. Okay. So it's just an object. Right? It's got flat surfaces, no curves. Okay, so that's a big deal. It has no curves. It has flat surfaces. So I think the definition of polyhedron that I've seen in other textbooks, they use polygons as the faces of this object. Now, obviously, you don't know the word face either, but that's something that we're going to come up with. Okay, so I'll let you write that down. Now, I'm going to give you a picture here of polyhedron, kind of the idea and what most people think of like terms and stuff. All right, so polyhedron, solid flat surfaces. So here's kind of the idea. This is what most people think of like a polyhedron. It's a random shape. It's got a bunch of flat sides to it, right? Now, typically, most people think of like bases, right? That's a vocabulary word that most people think of. Bases are just the top and bottom of the object. Very, very straightforward. It's got a top, it's got a bottom, those are bases. The other sides of a polyhedron are just polygons. So what are these objects? What is this shape right here? Yeah, it's a rectangle, right? That's just a face of it. It's one of the edges. The top is what? On this particular figure, the top is a pentagon. Okay. So it's not a big deal. They're just picking polygons and putting them on the different walls and connecting them. Okay. Now, obviously, I don't know how you see this figure. I don't know if you see like this dashed area is going to the back of the object. Okay, so I don't know if you see that this point right here is going to the back or if it's in the front. I don't know how you see that, but it doesn't matter. I mean, it's a three-dimensional object. Okay, now the other words that I've been discussing are the flat surfaces, right? We call those faces. Now, faces can be any shape. That's what you need to realize. No, they don't have to be rectangles. They could have been pentagons like I chose earlier, or a hexagon, or a dodecagon. So they can be different. Now, the other terms that most people think of, other than base, is the vertex. The vertex is where these corners meet. Okay, so these are the basic terms that we've used. But obviously, a face is just one of the flat surfaces. So sometimes we call the bases the faces. Yeah, rhyme on purpose there. But okay, any questions with the main terms here? I just thought these pictures definitely help you. They see like, what am I talking about when I say base? It's just what it's resting on, or the vertex where the corners meet. Now the other words we did discuss is like the edges. The edges are just the walls. It's where the faces intersect. So like, for instance, on this picture, right here, this bottom line here, this is an edge. It's just one of the walls of your polygon, which is the exact same definition we used earlier. It's just a line segment where the faces meet. But again, face, edges, vertex, bases, they're all the same. The other thing that we were talking about here is the vertex, obviously on this picture, has the same definition we've seen earlier. But here's the difference. On a three-dimensional object, notice that, oh geez, I spelled the word where wrong. Not even one. Can't handle that. That's embarrassing. Ah! I can't believe I just did that. Okay. The point where three or more edges meet. On a polygon, what we talked about back in chapter 1, like way long time ago, when we talked about a vertex, only a vertex is where two walls meet, right? Two or more. Well, this one says three or more. The reason being it's three-dimensional. So on, every corner here, there's going to be three segments that touch it. Three actual segments. So up here you can really see it, right? There is three walls that touch that vertex. So that's what you need to realize. That's what makes it three-dimensional. It's not just a length and width. Now it's length, width, and a depth, or length, width, and a height to an object. So we call those vertex. Almost the same exact definition. So these two words you should be very comfortable with. Edges and vertex. Face is the new one, obviously, and base, obviously. I think those are common sense stuff. Okay, now, so if I start using these words, you should hopefully know what I'm talking about. Faces are the actual shapes on the walls. Edges are the actual lines themselves. So that's something that you should expect for future homework. They'll ask you to find how many edges are there on this particular shape, in kind of the walls, that type of thing. But what most people don't understand is the different names of these polyhedrons. Okay? That's what they don't. That's what you do. A lot of people don't realize that there's a ton of different types of polyhedrons, the names of them. So that's what we're going to go through. But before we do that, let's talk about the word that I talked about earlier, a regular polyhedron. Because that's what most people think of when they think of these shapes. You probably don't think of this shape right here, that weird pentagonal shape. You think of very clean, crisp looking pictures. And that's what we would call typically a regular polyhedron. Most people think very symmetrically in their head. Objects are very clean, all the walls are exactly the same sizes, all the angles are the same. It's a very clean picture. This is what most people think of. Now the definition of regular is the same definition we used earlier. It's a polyhedron where all the edges are congruent, and all the faces are regular, the regular polygons. And more importantly, all the faces, other than just being regular polygons, all the polygons are actually congruent to each other. So every wall is the exact same shape connected. That's what most people think of polyhedrons when they think of a three-dimensional object, other than maybe a square pyramid here, or this weird hexagonal prism kind of thing. So what I think we're going to start with here is, let's start with these regular polyhedrons, so we can see kind of what these shapes look like. And once we get some of these shapes, then we'll go back and we'll look at the regular names. Okay, so these are special, right? Most polyhedron are probably never going to be regular. It's very specific. The walls have to be the exact same shape. They all have to be congruent. All the walls have to be equal. All the angles are equal. Very limited. And I even I gave you that hint earlier. If you're into Dungeons and Dragons or those board games that require very weird, fancy dice, this is the type of dice you're using. You're using regular polyhedra. Right? So let's jump into that first. But here's my question: does anyone need that definition or anything on this page? Okay, these go online. So remember, if you go to my website and you click, you can actually just click through the PowerPoint and it'll actually play for you. Now, obviously, I won't do all this fancy animation, but they'll be there. You can write them down. You can download them. You just drag them to your desktop on your Chromebook or at home PC, something like that. Okay, so let's talk about these regular polyhedra. So the regular ones, obviously, they have the same. They have the regular faces, congruent polygons. All the edges are congruent. But here's the different 5 types that we have. And there is more than 5. These are just the main 5 that I want to show you, because otherwise the pictures get so complex you wouldn't understand them. The first one is called a tetrahedron. Tetra is where they have 4 equilateral triangles for the walls. 4 equilateral triangles. Now, what does equilateral mean? What is equilateral? What can you tell me about that for triangles? All the walls are the same. So this picture is literally going to have 4 triangles. There is 4 there. It's kind of hard to see that. But every wall is exactly the same triangle. So like they try to do a nice little job of shading, right? So you got this front side, you got this front side, you have a back wall, and then you have the bottom like plate, the base that it sits on. But every single one is the exact same triangle. They're all congruent, all the walls are equal, all the angles in the corners are the same. That's a tetrahedron. Okay? A lot of people don't understand that. They've never seen that word before. Or you've heard of it, but you didn't realize what it means. Then there's hexahedrons, which are cube. So it's 6 square faces. Okay? So this is what it looks like. That's a traditional like picture that most people think of like a 3-dimensional. They think of the cube, like the sugar cube, or the triangle like idea, the triangle pyramid, which they call a tetrahedron. But notice the name, right? Hexahedron, hex being like a Latin word for 6. I'm surprised they didn't call it a quadrahedron, but they actually used a tetrahedron. I'd have to look up the Latin word for tetra. I'm not familiar with that term, other than just knowing that it's a triangle pyramid, that type of thing. But squares. What do we know about squares? What can you tell me about squares, like square faces? What's special about a square? All sides are equal, all angles are equal, it's parallel walls, it's a 4-sided figure. You know, it's the regular quad. So they're actually picking regular quadrilaterals for all, all 6 walls. So there are 6 walls: top, bottom, right, left, front, back. Okay, we traditionally call that the cube. Okay, the top one we traditionally call that a triangular prism, or triangular pyramid, because it is a triangle for a base and it is a pyramid. Some of the pyramids in Egypt are triangular pyramids. Some are square pyramids, like the Great Pyramid of Giza is square. All right, next one is an octahedron. What is the root word of octa? 8. So it's got 8 faces. 8 equilateral triangular faces. It's so hard to say. 8 equilateral triangular faces. So here's what it looks like. It's got 8 faces, and they're all the exact same triangle. Things that I can think of that would be in that shape would be like an ice crystal would be kind of this shape in octahedron. And then they would branch out and connect them more and more. But they traditionally are like very symmetrical. All the faces are exactly the same. So there's 8 equilateral triangles there. Now the next one, obviously, we're going to go to, instead of the triangulars, we'll go to other shapes. So like the dodecahedron. So what do you think dodeca means? Nope. 12. No. Pentadec would be 12, but this is dodec, so there's 12 faces. And this is weird. There's 12 regular pentagonal faces. So this is super hard to see. But you have every wall is a pentagon, and they're all the exact same. Now, all they're basically doing is figuring out the different methods of connecting triangles, squares, pentagons, hexagons to make different shapes. Now, I know for a fact that you can't take a hexagon and like make more hexagons off it, and they'll all connect perfectly. Like if you ever looked at a soccer ball, you can't just have hexagons in the shape. Some of the shapes on a soccer ball are also pentagons, so that doesn't work. That would not be a regular polyhedron. Polyhedrons have to have the same shape in every face. So that's why I'm like this one, they're all pentagons. You can see every single item there is a pentagon. So we're looking on the top down at that object. So you can see that. So there's only certain shapes you can make by putting all these faces together. There's certain ones that don't work. Okay, and then there is one more here that I'm familiar with. Is the icosahedron. And that is 20 faces. 20 equilateral triangles. And this one is like insane to look at. I can't even, like, looking at that picture, I can't even wrap my head around, like, how they did it. Like, I can't see, like, where the front and the back is. I can't see it because there's dashed lines there. So, but every face is the perfect triangle. It's an equilateral triangle. This is the one that, like, if you're in Dungeons and Dragons, that'd be like the dice you use, the 20-sided die. That type of thing. There's certain, and if you're very familiar with board games, there's certain dice that you can never make because there's no way to make like the same sides that they're all equal in faces. So, but I mean, honest, raise your hands. How many people have actually heard of these terms before? Yeah, see, that's what I'm saying. Like, most people have never heard these terms before. They know the shapes, what they look like. They're very familiar with like cubes, or they're very familiar with maybe the pyramid shapes. Didn't realize that there's like different types of pyramids, but just the original pyramid, the triangular pyramid. But I mean, these are the special ones. These are regulars. So I just thought this is interesting. I thought I'd better show you this because I think it would be an injustice if you never get to see these in your life. So, but these are very, like, to me, and I took, tons of math courses. I don't see these all the time. These are just kind of one of those rarities you get to see in geometry class. Or if you're an engineer, you might use these at some point. All right. But I thought these were kind of cool. I wanted to show you them at least. Anybody need these still? Like you're still writing them? Just thought these were fun. All right, but let's go to the polyhedrons, not the regular ones, just the normal ones, and let's talk about like the different shapes, like the ones that most people are very comfortable with, not those tetras and dodecahedrons. Let's talk about just the normal polyhedrons, the normal three-dimensional objects that people are familiar with. So these are what we call solids, the ones that most people are comfortable with, the ones that you normally see in like an elementary school. Okay, obviously the prism. Most people know what a prism is. Okay, prisms are where a polyhedron will have two of the walls are actually parallel. So two of the bases are parallel to each other. And the big thing is the parallel faces are also congruent to each other. So there was a shape I showed you earlier, it was this one, right? So this shape is a prism, okay? And how you typically name it is you name it by what the bases are. So the parallel bases would actually name that object. So in this particular case, what is the shape of the base on the top? How many walls is that? 5, right? So it's a pentagon. So what this shape would be called is this would be called a hexagonal prism. So that'd be the idea. You name it by its base, and those bases have to be parallel to each other. Okay. Now the other walls typically are just they're just polygons, but we typically name it by its bases. That's why I showed you that picture earlier. Okay. The second one that most people are familiar with are the pyramids, right? Pyramids are polygons, or polyhedrons, I should say, where a polygon is the base and it has 3 or more triangular faces. So notice this, it has to have 3 or more triangles. So 3 is the minimum. And where they meet at a vertex. So this is a different picture. I want to pick a different picture than the one I showed you earlier. The earlier one I showed you, the tetrahedron, was the triangular prism. What is the base on this one? What's the base here? What shape is that? What? Say? It's a quad. It's actually a square, right? So it's a square or quad. Yeah, you're right. What we call this one, we call this a square pyramid. The picture I showed you earlier, that tetrahedron that I showed you earlier, that was a triangular prism, or a triangular pyramid. Because it had a triangle for the bottom base. But this one actually has 4 walls, as opposed to the last picture I showed you was 3. Okay, I just thought that was interesting. But you still name it by its base. It's a square pyramid. Because the pyramid comes up to a point. The normal prisms don't. They have flat walls that are parallel. Okay, then the other one, obviously, the ones that are not solids, that are not considered, they are solids, but they're not polyhedrons, are the ones that have curves to them. So these are like cylinders, right? The cylinder, by definition, is a solid where it's got congruent circular bases, but they're parallel to each other, kind of like the picture I showed you earlier, the hexagonal prism. But the circles are parallel to each other, they're equal, and then there's just a curved surface that connects them, like this. Like a pop can, or a glass, like a glass you drink out of, would be a cylinder, right? thinking technology-wise, because I always like to wrap technology in this stuff. That Mac Pro that Apple makes, it's a cylinder in shape. The reason why they went to that shape, it's iconic looking. No computer's ever been circular before like that. But it's perfect for air cooling. Like, all they have to do is spool a fan in the middle of it, which they did, and it actually just creates a vortex and it sucks all the heat out. If you've ever seen that Mac Pro, it is gorgeous looking, but that thing can literally melt your desktop because it's blowing air out, and that air is super hot with all the cores for the processors and that thing. But they used this design. They just used a cylinder because it was elegant looking. The inside of it, when you actually look at the actual the chips that they put in there, they put the chips in a triangular prism shape, triangles that were formed a prism, and I'll show you that triangular prism here in a minute because we'll come back to these shapes. We'll break these down to more different ones. But I just love that design. I think that was definitely iconic. It's not probably the best for any professionals that want to upgrade their computers, like people that are really tech savvy. They can replace a graphics card. You can't really do that on those, but they're just cool looking. I love that design. All right, the cone obviously is the same type. It's kind of like a cylinder, but now it comes to a point, right? So it's a solid. It's got the circular base, but then it goes to a vertex at the top, like this. So do you notice how we have prisms and pyramids, right? They almost are like the same style as the cylinder and cone. The cylinder has parallel faces, the bases here, and the cone has the vertex, kind of like the pyramid, right? So there's kind of one of each. But now there is an extra circular object that is still not considered a polyhedron because it doesn't have the flat sides, those flat edges. But it's the sphere, right? Sphere, by definition, is the set of all points in space that is equidistant from a central point. So now, what does the word equidistant mean? Can anyone figure out what equidistant is? They just cram two words together. What is it? Yeah, same distance. Equal distance. So put them together, right? So here it is. It's like a bouncy ball. Now there's a central point or a golf ball. Maybe golf balls have actual bases to them. It's actually a type of polyhedron, or it's a type of polyhedron. But a sphere is very, very unilateral. It's perfect in design. Equal spaces, like most planets are. Earth, actually, and this is the crazy part, Earth is not an actual perfect sphere. It's actually squished a little bit. It's actually shorter in height than it is in width. A lot of people don't know that. That's why, if you ever get to pre-calc, we talk about how to find distance on a globe. It's actually different if you head further north, like on a path with an airplane, versus if you head parallel, across the longitude line, or latitude, So you go just straight east-west versus going kind of north. It's actually a shorter distance. That's actually why airplanes tend to take a circular path when you go to your town. When they go from LA to New York, they take a curved path, not just a straight line, because it's actually a shorter distance by heading a curve going north. And it's actually faster because you take jet stream and stuff. But that's a sphere, right? So these are not polyhedrons because they have curves, but these are. But they're still solids at some point. But these are probably the ones that most people think of. Maybe not that shape, but maybe these are. Okay? All right, let's go down and let's take a look at the individual prisms. Because that's what I want to look at. I want to look at those actual polyhedra that are based on this shape. Where they have bases that are parallel and they have different bases. Right? So, the base, the polyhedrons are based on the shape of the bases, so that's why I told you earlier, we had that pentagonal prism. So, let's talk about the triangular prism. So if this item is based on its base, what are the bases on that picture? So look at that word. What are the bases going to be on this thing? Triangle. So there it is. The bases, which are actually the parallel walls, could be this top one and this one right here. They're actual triangles. Now, actually, I think I have an actual three-dimensional one. Yeah. So here it is. There's your triangular prism. The triangles are actually the top and bottom. They're actually the parallel walls. So there is triangles on the bottom. And then the other faces are just polygons that are just straight. They're not curved. So that's the type of triangular prism. Okay, this is the one that's like the iconic one that you see in like an elementary class where they show you how rainbows are made, right? Like if you had a glass triangular prism and you actually shine light through it, it distorts light because the refractions of the actual like lenses, the faces actually refract light, and it actually breaks the spectrum of light up into the different colors that you see. So that's the idea. Next one is a rectangular prism, right? So what do you think the bases are going to be? Rectangles. So there it is, right? In fact, on this one, I can't even tell which ones are the bases. I don't know if it's right, left, front, back, top, bottom. I don't know which one because they're all rectangles. It's like a shoebox, really. So that's the rectangular prism. But these, like for me, like when I think of the solids, those are the shapes. That's what it is. I think it's the cone, the sphere, and stuff. But this is what I come down to. It's those two. Now, obviously, there's a ton more because if you just pick a different shape, instead of picking rectangles or triangles, you could have picked, the pentagonal one, the one I showed you earlier. That was, I just picked a different picture, but I mean, this is the one where it has a pentagon on the top, pentagon on the bottom, and then the other walls are just straight faces. Typically they use rectangles for the other faces. Okay, triangular pyramids. Now, obviously, if I go back, there's more than this. Like there's a hexagonal prism, heptagonal prism, octagonal prisms. It's just however many faces you want to pick. You just put those top and bottom, make them parallel, and then just pick the other walls as actual rectangles. Does that make sense? Okay, now if we go to the pyramids, I should have probably separated. I probably should have lined here, but if you go to the pyramids, the one I talked about was the triangular pyramid. It has triangle on the bottom. This is the actual same picture I showed you earlier. I just rotated it a little bit. The base is actually a triangle. There's a couple pyramids in Egypt that are triangular prisms, or triangular pyramids, I should say, where the base is a triangle. The Great Pyramid of Giza in like Egypt, Cairo, those are square pyramids. So a rectangular, I call them square, but rectangular prisms, where the bottom's a rectangle. They're clawed. Those Great Pyramids of Giza are like, a lot of people don't know this, they're super, super exact. For me, they're definitely iconic for when I think of like ancient cultures. But I mean, just to give you to wrap your head around this, I mean, those objects, like those pyramids, and I'll show you a picture of these up. I'll bring them up here in a second. I'll throw it up here on the rough. They're perfect in design. I mean, the pyramids, there's three of them, right? The Great Pyramid of Giza. There's actually three of them. They're perfectly aligned. Where, I think there's the Pyramid of Khufu, which is the big one, right? And that's a square pyramid. I can do three-dimensional. And then there's the smaller one, which is for his queen. And then there was an even smaller one that was in the back. And there's a big one, and then they go smaller. But what a lot of people don't realize about those pyramids is that the face where the doorway is actually facing perfect north. Like perfect north. Like that to me is insane. That it's facing the perfect north for an ancient culture to find that. That they actually had the concept of where magnetic north was. They knew where it was. Okay? And the other thing is they're perfectly parallel to each other. The walls are perfectly parallel. I mean, the walls are facing perfect parallel. I mean, there's no taper to them. They're squared with each other. And the other crazy part is, other than just, being equally spaced, perfectly parallel to each other, is that they're perfectly aligned with the belt of Orion. If you're into astronomy at all, not astrology, but astronomy, right? The study of stars. The belt of Orion is an iconic constellation in the sky where, for the northern hemisphere, it comes out during the winter. So it's actually starting to come out now. You can usually find it like south of us, so this is north, right? So south, it's usually to the west, it's up in the sky. They're like basically the three brightest stars in the sky. And they're lined up, so if you ever look up into the sky and you'll see them, they're lined up like this. 3, and then obviously like there's more that would build Orion itself, an ancient warrior, right? But the 3 pyramids are actually in perfect alignment with those constellations. Like they have the same space, they have the same like tilt, like that one, the smaller pyramid is actually offset just a hair from the perfect line. And in fact, there's a chamber in the burial chamber of each pyramid that there's a little vent on the pyramids itself. There's a little vent in the actual burial chamber where if you looked, what they did is they put a drone in there. They put a little RC car with a GoPro on them, and they drove it up the ramp, up that little like that air hole, right? Because that's how when they're building, they have a air chamber so they can actually breathe. That chamber actually faces the star that it's directed to. It's actually perfectly aligned and it looks directly at that star. How weird is that? And it's super exact. I mean, when you look, when they drove that little RC car up that ramp, it was that little vent where that RC car was sitting was perfectly squared. It wasn't like all jagged and there was like sharp edges. It was groomed perfectly. And I mean, how they did that is they did that on the fly when they were building the pyramid, going spiraling upwards. So they had this greater grand concept of where the air shaft was going to be and how it was going to line with the star, so that way when they put all those bricks together, that shaft was built perfectly through all of them, which is crazy to me. How like exact and how the architecture was put together with no like modern technologies. This is built with literally levels, string, and water, and sand, like limestone sand. So, and those bricks are like, I think one of the bricks is like 2 tons, so 4,000 pounds, okay? And they move those with human power using rollers and stuff, which actually makes it a lot easier. But I mean, they brought them from very, very far away. I mean, some of those stones were not found in Cairo. They were found in towns in like Israel and other areas, and they're literally moved all the way there so they could build them. So I'll show you a picture of like the grand scheme of things here in a minute, because I did hint at these when we talked about the different shapes for the polygons. But we'll come back to that. But this to me is like, I love history. I took a ton of history courses in college. I'm nearly minor in it. I took a credit or 2 shy of it because I just thought it was interesting. I love the architecture of it. Okay, then there's obviously a pentagonal pyramid, which is the bottom is a pentagon, and you can pick any other hexagonal pyramid. I've never seen like an actual example of a pentagonal pyramid in like ancient cultures. Where you see something like this in more modern, I guess, would actually be like the Native Americans when they build huts. They actually use that shape. So tomorrow, I'll definitely on the slide, I'll put in those pyramids of those pictures of the pyramids, and we'll kind of look at them so you can actually see what I'm talking about. Because I think it's interesting.
Come to the office, Caitlin Ayers, and the number sheet.
Wow, that's weird. I see some floating legs and a floating head.
I just saw that backpack. I was like, you got those
Right.
I was like, how's that backpack just floating?
The only part that she wants to be seen to is her legs. How ironic is that? What? What? I said the only part that Cassie wants to be seen is her legs. How ironic is that?
What? No, this is the fall. This is where we're in the fall.
Yeah, this is fall attire. We're in a hat, man. Don't wear a hat.
Leggings! I got it from the store.
I always got
From the store. Oh my god.
where the hockey happens.
Oh yeah.
It's just small. Bryce could have defined it. We're always like,
I would have gone too.
People make funny because they have floating heads and a backpack.
Yeah, you gotta floating head and legs. I mean, that's all you need in life.
Yeah.
Floating head.
And like,
Oh, man.
that was really funny.
Honestly, they're in a rib cam. I'm like, half out. My parents are